In this video, our goal is going to be to come up with the inverse of a matrix. So, what is the goal of an inverse of a matrix? Well, let's think of this in terms of numbers first. Right? Let's say we have the equation ax equals b, and we want to solve this for x. Well, alright, we'd have to divide both sides by a, right? Well, instead of dividing by a, let me write it in a different way. It's the same thing, but we're going to write it in a slightly different way. Instead of dividing by a, I'm going to multiply by a to the minus 1. Right, and remember, the negative 1 power is just 1 over that thing, so it is dividing by a. Right? So I multiplied on the left here, so I'm going to multiply on the left over here. Though remember, for real numbers, the order doesn't matter. But we want to keep the order, or the correct order here, because for matrices, order does matter. Alright? So what happens here is these cancel out, because a time, or 1 over a times a is 1, and we get that x is equal to a inverse b. Right? Which of course is b over a, normally for numbers, but this is sort of the idea here. Now this is all true as long as a is not 0, right? Because if a is 0, then the matrix just, then the number just doesn't have an inverse, right? No multiplicative inverse. All right. So inspired by this, we define what a matrix inverse is, right? Or maybe before defining this, let's say what we'd like to do for matrices is have a similar kind of concept. Let's say we have a matrix equation, a times x equals b, right? Then what we'd like to do is try and emulate that. So try to ask, well, is there a matrix A inverse that I can multiply onto both sides here so that these cancel out somehow, and I'm left with A inverse B? Right? Is this possible? Well, what we're going to say here to define this is, so A, as it turns out, is going to have to be a square matrix. So A is going to be an n by n matrix. Okay. Then A is invertible. Right? It's invertible if there is a matrix. Actually, I should say there is an n by n matrix B such that A times B equals the identity, the n by n identity, but that should also equal B times A. Right? So in either order we multiply them, we should get the inverse matrix, or the identity matrix. Right? So in this case, B is the, we don't usually put this word in here, but it's the multiplicative identity, or inverse, sorry, of A. Okay? So if B exists, we say A is, invertible or non-singular. Right? If B does not exist, we say A is non-invertible or singular. Right? Kind of the typical words we'll use for this is if a matrix does have an inverse, we'll call it invertible. If a matrix does not have an inverse, we'll call the matrix singular. That's typically the words we use for this. Right? So, a fact here, this is actually a theorem. If A is invertible, then the inverse of A is unique. So we call it A inverse. Okay? So this is the important thing here. We have, in order to give this thing a proper name, we need to know that there's only one of them. So how do we do that? Okay. So to prove this, what we're going to do is say, well, suppose it's not unique. So we'll say, suppose B and C are inverses of A. Right, so suppose we have two things that are inverses. Right, then AB is the identity, but that's also B times A. And also AC is the identity, as is CA. Again, if B and C are both inverses of A, then when we multiply them together, we should get the identity. All right? So, what do we want to do here? Well, we're trying to show that the inverse is unique, meaning that there's only one of them. So our goal is to show B must equal C. Right? Because that means, well, if we had two different inverses, then they'd have, or if we say we have two different inverses, they actually have to be the same. So what we're going to do is start with A times B is equal to the identity, right? And then what we're going to do here is we're going to take both sides of this equation, and we're going to multiply it by the matrix C. Right? Well, C times the identity, if you remember what the identity matrix does, that's just going to be C. Over here, what we're going to do is use the associative property and switch around the order that we multiply in. Right? But, look here, C times A is just the identity. So this is just the identity times B. But again, identity times anything is just, that other matrix. So B equals C. Right? So the inverse is unique. Right? So there's only one possible choice for an inverse if it exists. So in the next video, we're going to talk about how we go about computing this. Hope this made sense, and see you then.